Hi everyone. Now we are going to start with our questions. So question number one uh, is about arithmetic mean. We need to calculate the arithmetic mean and the geometric mean. We actually have to calculate the harmonic mean, and we have been given the arithmetic mean and the geometric mean of a data set. So the data set contains six values, none of which are equal, and this is actually a feature, one characteristic of a good data set, that none of these are equal. So every value is different, and this will help us to evaluate a better result, a better picture, to paint a better picture. So arithmetic mean of a data set is 13.25, and the geometric mean of that same data set is 12.75. So we know, as per our equation, that arithmetic mean is greater than geometric mean, and geometric mean is greater than harmonic mean. So if we apply this here, arithmetic mean is going to be greater than geometric mean, and geometric mean is going to be greater than harmonic mean. So our question is that what will be the harmonic mean? What would be our harmonic mean? Arithmetic mean is 13.25. The geometric mean is 12.75. And the harmonic mean, we need to identify what should be our harmonic mean. In between, we have options. We have three options in between 12 to 75, 12.75 and 13.25. This actually eliminates our first option. We need to use this thing. Greater than 13.25. It cannot be greater than 13.25. So this eliminates our second option also. And now the third option is the harmonic mean will be less than 12.75. And this is the correct answer, because as per our concept here, our harmonic mean is going to be lesser than geometric mean. So this is the only possible option which looks correct here. Just because there is theory, there will not be direct questions. They are going to test the concepts using indirect, they will give you a situation using the indirect ways. So there will be indirect questions about theories. Don't assume that there are going to be straightforward direct questions. So you need to have a clarity on the topic you read. So that's why the videos are longer than required. Uh, that's the main reason, so that we could clearly discuss every possible scenario and we do not miss anything. Okay, so let's move to question number two now. So question number two here is that over the last 4 years, an investor's portfolio has the following returns: 5.26 minus 2.10, a negative return, a return of 3.86, and 18.18. The mean, the arithmetic mean of this return is closest to what would be the option. So I need to add these values simply. 5.26, I will subtract 2.10, I will add 3.86, and I will add 8.18. And I will divide this by the total number of observations, which is 4. So let me just show you, let me just share my screen with you, and I'll try to hear the calculator here. Okay, so if you can see on my screen, the question was, the observations were 5.26. Then we add, okay, then we subtract that was the negative value. 2.10. Then we add back 3.86, 3.86, and then we again add 8.18. This is equal to 15.24. Then we divide it by 4, the total number of observations, and this gives us 3.8. So this is our answer. 3.8 is what we calculated. So 3.8 is our answer, and we do have option number A. So option number A is the correct option. And this is just a simple mathematical question. Nothing tricky about it. So now let's talk about question number 3. So question number 3, the question number 3, an analyst evaluates a data set with 8 values. So there are 8 values in this data set. From the data set, she calculates the geometric mean to be 8.5 if the arithmetic mean is equal to 8.9. The harmonic mean is closest to what? And this again, we are going to use our previous concept here also. So arithmetic mean is going to be greater than geometric mean and harmonic mean. So arithmetic mean is going to be greater than geometric mean, and geometric mean is going to be greater than harmonic mean. Analyst evaluates dataset with 8 values. The data from the dataset, she calculates the geometric mean to be 8.5. And if the arithmetic mean is equals to 8.9, harmonic mean will be closest to what? If we were to calculate this thing, now we actually need to calculate this. So we also have one more equation with us. We have the equation which the one more relationship. So another relationship between arithmetic, harmonic, and geometric mean is that arithmetic in mean, when we multiply arithmetic mean with harmonic mean, it's equal to square of geometric mean. So arithmetic mean, when we multiply it with harmonic mean, it is the value is equal to geometric square of geometric mean. So now we have the geometric mean with us, the value. We have arithmetic mean with us. So what we are going to do is we are simply going to plug these numbers in the equation. So 8.5 whole square, if we divide it by arithmetic mean 8.9, this is going to give us our harmonic. Let me just quickly share my screen, my calculator with you, and let's calculate this so that you guys also understand the functioning of the calculator. So 8.5, 8.5. Now I'm going to square it. So this is going to give me 72.25. Now I'm going to divide this by 8.9, and this will be equal to 8.12. So 8.12, 8.12, yes, we do have an option 8.12. So this is actually how we apply the concepts in calculation. Now let's move to question number 4. Question number 4 is it's assuming question number 4 is that assuming a little some variation in a data set. So there are three statements here, and we actually have to choose the correct one out of these 4 statements. So first statement is arithmetic mean is greater than geometric mean, which is greater than the harmonic mean. Arithmetic mean, they are saying arithmetic mean is greater than geometric mean, which is greater than harmonic mean. This is the this is what the first statement is saying. Then the second statement is saying geometric mean is greater than arithmetic mean. Geometric mean is greater than arithmetic mean, which is again greater than harmonic mean. This is this is what the second statement is saying. The third statement is saying that harmonic mean is greater than geometric mean, which is greater than arithmetic. Now you need to understand the questions here. And if you look at the, if you understand the question, you understand that the option A is correct. Because this is what the relationship, or this is what the relationship is between these three means. Means, I am saying means, not means, MEANS. Okay, the spelling is same for both of those. So when we talk about arithmetic mean, geometric mean, and harmonic mean, we are basically talking about averages. So simply, what we are discussing as of now, this is the fundamental and the basic building block of quantitative methods, and this will be help. This will actually help us with our uh, further studies. So this is actually, I will try to make it a little holistic way, so that we could connect where it will be used and how we are going to apply this in practice. So okay, so this is our relationship where arithmetic mean is greater than geometric mean, and geometric mean is greater than harmonic mean. And if you look at our question, so the option A is the correct option. All right. So question number five. So question number five is based on the advice of his financial advisor regarding dollar cost averaging. Client invested $2,000 each month. So client invested $2,000 each month into a blue chip stock. The stock price on the date of purchase each month over 4 month stretch was 12, 14, 11, and 9. And using the harmonic mean, then they're actually asking you to use the harmonic mean here. The average cost per share of the stock is closest to what? If you remember the formula for how to apply or how to use how does the harmonic mean looks like? So this is actually how harmonic means look like. Such as average cost of shares purchased over time. So just remember one example, mutual funds or systematic investment plan, SIP. So whenever you talk about harmonic SIP or mutual funds, so we apply harmonic mean. Why? Because every month we are investing a certain amount, maybe 1,000 rupees, $1,000, £1,000. Then there is an average price. So this we average out. So let's say that the average the average price is 10 rupees. So I am going to get how many shares out of this? So this is how actually we average out all these values. So this is what the formula is representing. Now let's get back to our question. Let's first, rather than before using the calculator, let's draw a rough uh, uh, framework here before we use our calculator. So each month they are investing into blue chip company, the stock price at the date of purchase each month. So this is a monthly data, not annual data, over 4 months. So 4 months, this is the average pricing. What you can do is either you can divide 2000 by 12, then you can do 2000 by 14, then you can do 2000 by 11, and then you can add 2000 by 9. So this will give you average number of shares, right? Uh, you divide 12,000 by 12. So how many shares did you bought? You divide 2000, you divide all these numbers by the share price, and this will give you the average number of shares. Then you add it back everything. You add back everything. Or what you can do is you can use the formula here, simple formula, the harmonic mean formula. So there are total 4 months. So you are going to add 4. This is the formula. Total number of periods is 4. You divide them by 1 divided by 12, 1 divided by 14, 1 divided by 11, and 1 divided by 9. And this is going to give you your average value. Now let's do this on the calculator function. How you will also get to know how we are going to use calculator. Okay, so let me just clear everything first. 1 divided by 12. This is going to be 0.08. Now I'm going to store this, and there is a function called store and recall. I'm going to store this in value in our key value 1. I'm going to store this in key value 1. I will tell you in a moment how do we use this. Then I'm going to clear my screen. Then I'm going to divide 1 divided by 14. And this is going to be 0.07. Now I'm going to store this in key value 2. Then I'm going to calculate my third option, 1 divided by 11. I'm going to store this in key value 3. I'm going to clear my screen. Always remember to clear your screen. When I divide 1 divided by 9, and this is going to give me 0.11. I'm going to store this value in key 4. Now, what I'm going to do is I'm going to recall 1, add, recall 2. I'm going to add that. Recall 3, I'm going to add that. And recall 4, I'm going to add it. So my denominator is actually calculated now. 0.35, just remember the value 0.35. So this value is 0.35. I've calculated this value, it's 0.35. Now again, let's go back to the calculator. Now 0.35. Now I want this value in the denominator, and I want 4 in the numerator. What I'm going to do is I'm going to inverse this value. I'm going to click on 1 divided by x. This is going to inverse. Now this is going to put this value in the numerator. I'm going to multiply it with 4. This is going to give me a value of 12.83. Okay, so this is actually giving us incorrect values. So what we can do is we can simply divide 4. We can divide it by 0.35, and this is going to give us a value of 11.43. So 11.43. Now, if we look at our options, uh, 11.43. So we can eliminate option A, we can eliminate option B, and 11.43 is somewhat in between option B and option C. So any of these could be our uh, any of these could be our the correct option. And if we look at the arithmetic mean of all these four values, 12 plus 14 plus 11 plus 9, and if we divide it by 4, so if we look at the sum total of the total is of 12 plus 14 plus 11 plus 9 is 46. If we divide it by 4, the value is 11.5. So if we look at the arithmetic mean, it's going to be 11.5. So arithmetic mean will be greater than arithmetic mean is going to be greater than the geometric mean, and geometric mean is going to be greater than harmonic mean. 11.5 is the arithmetic mean. So This is the arithmetic mean. We have calculated that. Now, the only possible value we can choose as an option is option number C. So this is kind of tricky. Yes, but you need to understand if there is anything, any other information given in the question, you need to incorporate that information in your findings or in while looking for a solution. I hope this was clear. And this is actually tricky. Yes, there are going to be tricky questions also. There are going to be easy questions also. Let's move to question number six now. So question number six is uh, the product of the arithmetic mean and the harmonic mean is what? So they are asking about the product of the arithmetic mean and harmonic mean. You need to remember this relation correctly because at times they might ask you a relation the product of arithmetic mean and geometric mean maybe. Then you need to re-engineer the formula. You need to calculate the correct product. So the product of the arithmetic mean and the harmonic mean is this is the square of geometric mean. Square root of geometric mean? No. Geometric mean? No. Square of geometric mean. Also pay attention to the given options because at times they actually use tricky language. So you need to pay attention to. Now let's move to question number seven now. So question number seven is that there is an investor who buys the stocks on March 24 for $63.25, and the stock pays quarterly dividend of 0.54 on May 1st and August 1. On September 27, the investor sells the stock for 62.80, 62.8. Investors holding period return is equal to what? So now here in this question, they are asking about holding period return. If you remember the holding period return, the holding period return is from you use the ending value, you subtract the beginning value, you add back the cash flow, and you divide it by the beginning value. And this is for single period holding return. When we have multiple multi-period holding return, then we actually need, then we will be requiring the, then we will be needing the rates here. Okay, now we'll move. Let's go to the question number seven now. To understand this thing, for this we actually need to have a timeline. Investor buys on March 24. March 24, they bought something. The stock pays quarterly dividend on May 1st and August 1st. They sold the investment, they sold the stock on September 27. September 27. So this is 3 months. And this is where he got his first dividend. And this is here he got his second dividend. Dividend one and dividend two. So this is our investors sold it for 62.80. Now we are going to add back the dividend 0.54 twice plus 0.54 and now understand this thing. They are asking about the investors holding period return is closest to what? Because they are actually asking for holding period return, the beginning and the ending dates are irrelevant here. And if we had been asked to analyze the return, then we will be needing to know the length of the holding period. Then we divide this by the beginning uh, beginning beginning balance. So this is what he bought it for. The investor sells the stock for 62.8. We subtract 1. Or you can do is you can subtract 63.25, the formula, just like the formula we have discussed. And if you calculate everything, so this is going to give us in the holding period return of 1%. Let me just quickly share my calculator and let's calculate this thing on the calculator. 6.2, 62.8 is the ending value. At the end, the investor sold this stock for. Then we add back 0.54 and 0.54 again, because these are the two dividends received by the investor. And we now subtract 63.25. This is the numerator, and if we divided this by our beginning, the price which we bought it for, 63.25, this is going to give us a value of 1%. If I need to convert this into percentage, I will multiply it with 100. And this is 1%. I hope this is clear. And you need to calculate with precision. Now, our last question, question number 8. And the last question is that stock XYZ purchased on January 2 at the price of 12 per share. Investor received a quarterly dividend of 0.60 on April 1st, and the stock closes on June 30 at $13 per share. The holding period return is closest to. Again, we have all the relevant information. 13 is the ending price. We subtracted we add back the any dividend we have received. We subtract 12 out of it. And then we again divide it by the beginning price. This is going to give us 1.6 divided by 12. And if we calculate this thing, uh, 13 minus 12 plus zero point 0.6, 1.6 divided by 12, this is going to give us a return of 13.33%. I hope you do not have any confusion regarding the holding period returns and arithmetic mean, geometric mean, and harmonic mean. Okay, so we have completed LOS 1B. Now, in the next reading, in the next session, we will be starting with LOS 1C. Okay, thank you. Thank you for attending the session.